Okay, so I'm gonna go through this question here, question 17 from the latest self-test I handed out. And yeah, so just to preface this, this type of question here is more or less what we talked about in back in the day in line A2 learning task 10. So I just want to flip there for a second. Um, so we're talking about bridge circuits. And so here's an example of a few bridge circuits in the traditional form where they have two sets of a bunch of parallel resistors in series, but a counteracting parallel branch as well. I shouldn't say counteracting, like counterpart. Okay, so remember that in this particular case, we have 120 volt source. And as you go through each of these equally valued resistors, let's say the first branch, it's going to drop according to the proportion of the amount of resistors. So here we got 1, 2, 3, 4, 5, 6. And so if we take 120 volts divided by 6, it's going to, there's going to be a voltage of 20 volts across each individual resistor in this branch. Because they're in parallel, you're going to see the same thing in the circuit's counterpart branch here. Okay, so that's your traditional bridge circuit. And what the book goes over is if you create a bridge in between these 2 points here, then you can potentially have current flow going across that bridge. And you're only going to get current flow if there's a difference. Remember, voltage is always the difference between 2 points. Only if there's a difference are you going to get current flow. And the direction of that current flow is dictated by the more negative side and the more positive side. So we know that current always flows from the more negative side, the point of less potential, to the point of higher potential. And so in this case here, we have 60 volts attached to positive 80 volts. Well, the positive 60 volts is more negative by 20 volts than 80 volts. And so therefore, it's going to flow from positive 60 to positive 80. If you have a bridge connecting 2 points of the same potential, you're going to get zero current flow. And this is the same principle as birds on a power line, because both of their talons are attached to the same voltage potential on that power line. No current can flow through that bird. Likewise, this bridge here is going to produce zero current. And our third example here, a bridge connected from 40 to 80. Well, current's going to flow from 40 to 80 because positive 40 is more negative than positive 80. All right. Now, one other note here is that we have our source here, and we got a negative side and a positive side of that source. And as soon as we go up this particular rung, well, what we can say on this particular circuit is that this resistor, because it's closer to the negative of our source, is going to be a lower value voltage than up here, 120 volts. All right, so because this point here is closer to our 120 volt positive side of our source here. So we call that positive 120 volts. We call this side 0 volts. All right. Okay. So let's take those concepts into this particular question. All right. So I'm going to redraw this circuit in the more traditional like bridge circuit format on So tilting it over 90 degrees on its side. And just to avoid any confusion, I'm gonna just accumulate these two voltage sources into one voltage source. Doesn't really matter. All right, so our first rung is just gonna be one resistor. Second rung is gonna be made up of two resistors. And our third rung is gonna be three resistors. Now, all resistors are equal in the circuit shown. So that's an important concept to grasp, or an important point. Now, we're going to add in our reference points here. So notice that R1 is closest to the negative here. So I just want to make sure I get that right. So this would be R1, R2, R3, R4, R5, and R6. We have a few points to indicate. So at that point there, we have A, we have B right here, and we have C right there. And this would be called line 1, and this would be called line 2. Okay. Now, I would recommend putting in any sort of voltage value into the source, and that's going to help you visualize what's happening in this particular circuit. So let's go ahead and do that. And we'll use an easy value of 10 volts. All right. And so I'm going to start adding those the voltages across each of my resistors. So I would have 10 volts across R6 because they're connected. Each arm of that R6 is connected directly in parallel back with the source. So we're going to see the full 10 volts. We're going to see 10 volts from this point to this point along that branch as well, but it's going to be divided amongst two equal resistors. So we just take that 10 volts and divide it by 2. And so we have 5 volts and 5 volts. All right. And then we do the same thing on this branch here. From that point to that point is going to be 10 volts. Again, directly in line with our line 1 and line 2 across 10 volts. But this time divided among 3 resistors. So we're going to end up with 3.3 repeating 3.3 repeating across each of those. Okay. So now we're gonna add in let's add in some polarity as well. So this would be our negative, positive. This would be negative. This would be more positive over here. This would be negative, and this would be more positive over here. And that's dictated, of course, by the source here, as we have a negative and a positive. And so the side closest to the positive is going to be more positive. The side closest to the negative of the source is going to be more negative. Okay. So now let's go through the different options that it gives us. So A, C is positive. C is positive with respect to A. All right, so point C here, more positive than point A here. Well, let's take a look. So if we just go back to our bridge here, as we're tracing through our resistors, we can start at 0 volts and work our way up to a positive value. All right, so our reference can be, we'll call it 0. So, well, yeah, like for example, if I put like a voltmeter across here and here. This side would be more positive than this side over here, which would be more negative. All right, so I would read 5 volts at that point here. Anyway, I digress. I don't know if that made a lot of sense, but okay, so what ultimately we're doing is we're trying to determine from this point here to this point here which side is going to be more positive, right? So at this point, I have dropped 5 volts, right? And so we could say at this point here, we got positive 5 volts right at A. At this point here, we go 3.3 volts, and 3.3 volts, that makes 6.6 volts. And that's going to be more positive than our starting reference point right here. So we went from our starting reference points over to this point here. So that's going to be more positive because it's closer to the positive source. This is going to be starting at a reference point, calling it 0. We'll go plus 3.3 plus 3.3, which gives us 6.6 volts. And again, that's going to be closer. It's positive because it's closer to the positive side of the source. And so we could say that point C is more positive than point A with respect to point A by 1.6 volts. So A would be your answer. Now let's just take a look at a few other options here and see why they would be incorrect. Okay. So still 5. Let's take a look at B. A is negative with respect to B. All right, so B is right here. And we've dropped from this point to this point. So we would be going from 0 volts to positive 3.3 volts. And then with respect to point A, which is going to be now plus 5 volts, it is actually more negative. So point B is more negative by 1.6 volts than point A. So B is more negative than A, so this would be incorrect right there. Now the voltage across R1 is greater than the voltage across R5. Well, let's take a look at that. The voltage across R1 we know is 3.3 volts with our arbitrary voltage. And it's not going to matter if we change the value of that voltage, it's going to change proportionally throughout the circuit with each of those resistors because they're the same value, they're not changing. And the voltage across R5 is 5 volts. So C is incorrect. And D, the voltage across R5 is equal to the voltage between L1 and C. Well, the voltage between L1 and C is 6. If we take this point here, starting at 0, we get up to 6.6 volts. If we trace it all the way to C, 3.3 volt drop, 3.3 volt drop. So that's 6.6 volts we would measure. And R5 is 5 volts. So definitely not equal. So D would be incorrect as well. So our correct answer would be A in that case.